Okay, we're going to look at inverse trigonometric functions and finding the values of the trigonometric functions. So the first thing we need to do is look at a sine graph. So if we have a sine graph, we know that the sine graph starts at 0, it continues at 0 up to 1 and back down. So if we were to do a line test, we would have many points. So this would not have an inverse function. So what we need to do is to limit the range. So we can do this by just taking part of our graph. So if we do that, let's redraw it. If we take it, it's going to look something like this. And here we'll have minus pi over 2 at this point. And then here, this would be at pi over 2. So our sine has a range which is from minus pi over 2 to pi over 2. Now the inverse function, if it was to, well, I say the sine, we're going to use this with a range because the inverse function would look, oops, not very good drawing. So the inverse function would, try and draw it. So the inverse function would look like this with many points, which is not possible. So we need to limit between minus pi over 2 and pi over 2. Because this here, the value here is going to be minus 1. And this value here would be at plus 1. So this is when we switch the value. So we can say x is equal to sine y. Whereas over here, this initial graph, we would say y is equal to sine of x. So our values here, this would be at pi over 2. And this value here would be at minus pi over 2. So this is the area or that we'll be looking at. So to summarize the key concept, so the inverse function so we can say y is equal to sine to the minus 1 of x, and this is called arc sine. So this can be written also as y is arc sine x. So we can say the arc sine, and we can say y is arc sine x. So the domain, so we go back here. So for our sine graph, for the sine of x, so our domain is between the minus, so this is at 1 and minus 1. So the domain is minus 1 and 1. And the range, we said, is between minus pi over 2 and pi over 2. So this is for the inverse. So we'll just rewrite that by here. So the inverse function, arc sine, we'll say the domain is from -1 to +1. And we'll say the range is from minus pi over 2 to pi over 2. So now we're going to look at cosine. So cosine is the same, except it starts at 1. So we need to limit the range. So the cosine graph, if we looked at that, we would have to limit the range to from 1 like this. So this would be at 1, and this would be here at pi. So this is 0. So we can say for cosine, so the inverse function of cosine, so we've got the inverse component, so y is equal to cosine to the -1 of x, and this can be written or referred to as arc cosine, and we can also write it as arc cos of x. So our domain is going to be from -1 to +1, and the range is going to be from 0, so it's from here, from this point here, and it's going to be to this point here. So the range is from 0 to pi, or from 0 to 180, so we could also say 0 to 180. Right, so if we look at tangent, so the tangent graph we have within a domain. So we would draw our tangent like this, and this would be at minus pi over 2, and this would be at pi over 2. We have to limit it, okay? So if the inverse graph will actually look like, so you have, this would be at 1 and -1, and the graph will look like this. So this is the inverse. So this time, this here, because it's switched, this is going to be y is pi over 2, and this is going to be y is minus pi over 2. The range, so the range, say, is going to be minus pi over 2 to positive pi over 2. And the domain, because it continues indefinitely, is going to be from -infinity to +infinity. Okay, so we're going to look at an example of evaluating inverse trigonometric functions. And our first question is cos to the -1, or the inverse, of -1/2. So we need to find the angle for theta, but within the range, and there's two methods to do this. So there is using the unit circle. So we have method 1, and that is to use the unit circle. So if we have our unit circle, so we're looking for a point on our unit circle. So this is at pi over 2, and pi over the x value is when x is minus a half. So we know that the minus is got to be in the minus x. So this is in quadrant 2 or quadrant 3. So then if we look, this will be here when this is minus a half, comma root 3 over 2. So this angle here is what we're looking at, theta. And we've got to look at the reference angle. So this would be 180 minus our angle. So this is going to be, this is 120. So this is pi, so we'll say when theta is 120 degrees, cos of theta is minus a half, and so we can say cosine the minus 1 of minus a half is 120. And if we were to put this so into, this is going to be pi minus, so we've got pi minus, so it'll be 2 pi over 3. So method 2, I should put there, that's 120, which is 2/3 pi. So method 2 is using a calculator. So to use the calculator, we have to use the shift. So we've got the shift button, shift and cosine, and then in our brackets minus a half. So we can use the fraction button. So we could here use the fraction button, and then we'll put in there a half. So this will give us the answer of 120. And if you wanted to convert that into radians, so we'd say, so 120 times pi divided by 180, 60 into this 2 times, and here 3, so that would be 2/3 pi. Okay, so our second example, this is arctan 1. Now arctangent is the inverse of tan, so we're looking to find tan to the minus 1 of 1. So tan to the minus 1, so we can also say just tan, so tan of theta is equal to sine of theta over cosine of theta, because tan of theta is y over x. So something to remember. So first of all, we'll use the calculator. We'll do the calculator method. So the calculator, So we have shift 10. So we'll have, this will come up as to the -1. And we will use the bracket in 1, just equals. So this will come up as tan to the -1 of 1 is equal to 45. Now if you wanted to transfer this into radians, we can say 45 times pi divided by 180, and 45 once, and 45 4 times. So the answer would be pi over